Hi everybody. For cross sections today, we're going to be talking about bread, which I know that seems a little strange, but that is still what we are doing. So if you're wondering, that's on purpose. It's a little strange, and that's okay. So, excuse me. Many baked goods are not perfect solids like cylinders, spheres, or pyramids, nor do they have the symmetry of a solid of revolution, which means we can't just spin it and get the same thing. How will we find their volume? Today, we're going to explore this question by looking at a loaf of bread. A loaf of bread was baked on a sheet pan below. How would you describe the shape of the loaf? And what does each shape of each slice resemble? And are all slices the same size? So let's just start here with the loaf of bread that was baked on a sheet pan. The bottom is an oval. The top, which you can't really see in this, but we know that basically if you look at bread, the top is rounded, which tallest in the middle, if it's good bread. Okay. What does the shape of each slice resemble? So as I look at this and I'm trying to think of a shape I know, I'm going to say that looks like a semicircle. Are all slices the same size? Absolutely not. No, they are not. They're not the same size. Excuse me. They're not the same size because they're going to be larger in the middle and smaller on the ends. Okay. All right. So what information so so what we know by this is that our dimensions of each slice are variable. Not spell dimensions, put that E and I in one place. Dimensions of slice are variable. Okay. What information do we need to find the volume of one slice of bread, and how will we calculate the volume of one slice? So as I look at this and I'm thinking about that, that's a really good question. That's my first thought. And let's think about it. So we decided they looked kind of like semicircles. So I need to find the area of the semicircle. So I need the radius. I need to find the area of semicircle. In order to do that, I need the radius of the slice. And I can do that just by cutting the slice in half. Okay. We also need the thickness of each slice. And so the volume of one slice is equal to 1/2, because it's a semicircle, pi r squared. So this is the area of my circle, and that's my 1/2 because it's a semicircle, times the thickness of the slice. All right, so excuse the interruption. So the thickness. So we've got the volume of the slice will equal the area of the semicircle times the thickness of the slice. Okay. The slice is equal to area of slice shape, in this case, 1/2 pi r squared times thickness, which we're going to call the x, delta x, excuse me. All right. So how would you find the volume of the entire loaf of bread? Well, I'm going to add up all the slices. All right. How accurate do you think this method is for finding the volume of a loaf? How could you make it more accurate? It's pretty good. This is a good estimate. M is ridiculous. So approximation. If many slices are used, you can make it more accurate by using more slices. So in other words, the thickness of the slice would become, as we use more slices, it would go to 0. So delta x becomes dx. And our sum, we're adding up all our slices or summing them. Our sum becomes an interval. So what if our bread changed shape? So what if instead we're finding the volume of these coffee cakes you can buy from Hostess? If you look really closely, let's just kind of zoom into that Hostess picture for a minute. The shape of the slice is no longer round. And so the shape of our slice shape has changed. In this case, to a rectangle. And then if we look over at this crazy loaf of bread, I've never seen something like this, but this loaf of bread is a triangle. So again, our slice, actually this loaf of bread is an equilateral triangle. Slice shape, or slice shape of slice. That's probably better than slice shape. So the shape of our slice over here has changed to an equilateral triangle. And so what would change is the area of the shape, the slice we're using. So as we deal with cross sections, we might have semicircle cross sections, we might have rectangular cross sections, or triangular cross sections, or, I mean, lots of different choices here, but basically some geometric shape. Hexagonal cross sections and so on, okay? Now, please keep in mind that this one, where everything is exactly the same and the height isn't changing on the ends, this one would just be a triangular prism. But if it was taller in the middle than it was on the ends, we would need to use calculus for that. All right, let's take a look and go back down for our important ideas. Okay. So what happens a lot in these problems is the base will be some region that we're already really comfortable with dealing with, or somewhat comfortable with dealing with. So your base will be R, and then they'll tell you what kind of cross sections you have. So they might say you have vertical cross sections, which would be the red, of semicircles, or vertical cross sections that are triangles, or vertical cross sections that are rectangles. And so you draw a sample cross section so you know what your basic area is inside, which for the red I've called A of X. Or if you're going this way, they have you slicing perpendicular to the y-axis. Same idea, same shapes, but now we are cross sections in a different space. Write expressions for the area of one cross section, either using vertical slices, A of X, or horizontal slices, A of Y. Write the area for one of those cross sections, then set up your integral. If it's going to be perpendicular to the x-axis, it's going to be A of X, vertical cross sections. We'll go from the intersections from A to B, so X being A and X being B. If they are horizontal, let's actually put that in. A and B. A. This one would be B. And then if we go to the other, this is A comma C. This is B comma D. So that's a little bit different than what we probably would have written in the past. So that helps us kind of see what's going on here. Okay. Perpendicular y-axis, and so on. Okay. And that's that. We'll do check your understanding in the next video. Have a great day.